Good evening, sir.
Good evening. Good evening.
Good
Unable
evening,
to
sir.
share the screen.
Yes, yes, sir.
Uh,
Just,
just to allow it. It is
sir.
showing host disabled participant screen sharing.
Yes, sir. I am making host you, sir.
Okay. Okay. Okay.
I am making you. Yes, sir. I made. Yes, sir. Now you are host, sir.
Okay. Hold on. Yes. Yes. Yes.
So, sir, can we, sir, wait 1-2 minutes because
Just hold on one thing.
yes.
Let me. Just 1 minute. Huh? Just
Yes,
one
yes.
minute. Just 1 minute. No, I am also not expert of everything. I made lot of mistake. First, let me share my screen. How to do this? It is showing DDAS, then it is showing NIT Kurukshetra, but I have opened all the file. But share. Let me share. Then now it has now screen is visible, no?
Yes, yes, sir. Now it will be
Now it is visible, no?
yes.
Ha.
Yes.
Listen. Shivam, I will restrict it to 1 hour, right? I have developed throat problem for last 3-4 years.
Okay.
So maybe 1 hour virtual power plant and microgrid. After that, little bit I'll talk about zero bus load flow, right?
Okay, sir.
And this will this thing, because in class also I have reduced my decibel in shouting. And why data what to read little bit, and that's all.
No, sir. Actually, sir, participants should know about you, sir.
Okay. Read. Then we'll start. Okay. Okay. When you will tell me to start, I'll start.
Okay, sir. Just, sir.
Okay.
So now I want to welcome you. Sir already came. So healthy good evening to all of you for session 2 of ATAL FDP program. So this FDP program for hybrid microgrid opportunity and challenges for renewable energy resources. I am Dr. Shivam, Assistant Professor of Electrical Engineering Department, NIT Kurukshetra. I am co-coordinator of the ATAL FDP. I heartily welcome Chief Guest of the Day, Professor Debapriya sir, in Department of Electrical Engineering, Indian Institute of Technology, Kharagpur. I also welcome Coordinator of the ATAL FDP, Professor Ratna Daya, who is the coordinator of School of Renewable Energy and Efficiency, Professor in Electrical Engineering Department, NIT Kurukshetra. HOD of Electrical Engineering Department, Professor Swani Kumar sir, and the faculty members and participants of the event. The primary objectives of the ATAL FDP is to provide a national forum to the faculty and research scholar to share the basic knowledge with and objectives of understanding the concept, aspects of penetration of renewable energy sources, electrical vehicles, and with hybrid microgrid operation. Now, I would like to address of today's session speaker, Professor Debapriya sir. He is the professor in Electrical Engineering Department, Indian Institute of Technology, Kharagpur. He did PhD from Indian Institute of Technology, Delhi. He mastered in Power System Engineering from the Indian Institute of Technology, Kharagpur. He did BTech from Electrical Engineering from Kolkata University. He served many reputed institutes as Birla Institute of Technology, Ranchi, Theri, New Delhi, BITS, Palani, Rajasthan, Indian Institute of Technology, Roorkee also, and in last he joined IIT Kharagpur since 1997. He has taken various online courses for NPTEL as Power System Analysis, Power System Engineering, Fundamental of Electrical Engineering, and Power System Dynamics, Control and Monitoring. His research area mainly operation of distribution system, operation of grid connected microgrid, operation of islanded microgrids, impact of grid to vehicle on the distribution system. He has guided more than 20 PhD degree students and more than 40 MTech students for their master thesis. Currently, many doctoral students are working with him for their PhD degree. He has published book and book chapter. In that, Electrical Power System is the book publisher New Age International Private Limited since in 2007. 5 book chapters published by IIT Power Energy Series, Springer, which is under Academic Press and John Bailey and Son. He has published many international national papers. If you are interested, you may see on Google Scholar link. Now, I welcome you, sir, for this session. Thank you, sir.
Okay, thank you. Thank you very much. So, good evening to all the participants. Right. So, after maybe 1 month back, I gave lecture somewhere this online mode only. And I will restrict to I have 2 parts. First part is the virtual power plant and microgrid, the differences between virtual power plant and microgrid. Virtual power plant is the new thoughts, has emerged something like this. And microgrid nowadays all over the world people are working, right? So the first part, there is no mathematics. Second part, slight mathematics is there, which is known to everyone, those who are in power system engineering. So generally a renewable based microgrid can be understood as a particular case of, this is not a PPT, this is what I have done. This is a PDF file. So only I have made various color. I am not expert of making PPT, right? But same thing, Shivam, I'll send it to you after the presentation. So a renewable based microgrid can be understood as a particular case of a more general concept called a smart grid, which is an interdisciplinary term for a set of technological solutions for electric power system management. So smart grids are understood to be the key enabling technology for renewable energy development, electric vehicle adoption, and energy efficiency improvements, right? Sometimes the smart grid represent a vision for digital optimization of electric power distribution and transmission grids as applied to current operations, enhancing the grid security and opening up new ways of tapping alternative energy sources, right? So this is some kind of nowadays the hot topic of research is smart grid, microgrid, then demand response, then vehicle to grid, grid to vehicle or electric vehicle, and of course battery energy storage system, right? These are the whatever I have found, these are the very hot topic for the research. And particularly the demand response, the incentive based demand response and price based demand response, these are very hot topic nowadays, looking at the various articles. And virtual power plant also is coming up, taking shape, but it will take some time, right? So By using the internet protocol on home devices, the smart grid would be able to shuttle information back and forth between the distributed electric utilities and consumers, right? Microgrids may be a hot topic among those forecasting key future trends shaping the world's energy infrastructure, but few significant state-of-the-art commercial microgrids are actually up and running in the world. There are many now, right? So actually, academics from the University of Wisconsin-Madison, an institution often credited with the birthing of the microgrid concept, at least in engineering terms. That may be 40 years back, maybe early 80s. But if you look at the first power station or this thing, that is 1882, that was by your this thing Edison, Thomas Alva Edison, right? He actually started first power station, and that was very low voltage those days, low voltage DC line, and that microgrid term was not there in those days. But whatever we are talking about the today's microgrid, perhaps it is like Edison fast power system that started in 1882 and today 2022. So within 140 years, things have changed. I mean, in a very fast way, right? So that is, although academics of the University of Wisconsin Madison, they actually credited with the birthing of microgrid concept, but people say no, the first one, whatever it is, that first power station, the addition later little bit is there in that slide, right? That is nothing but that was nothing but a today's microgrid. Although in those days there was no term called microgrid. Yet current trends appear to make microgrids an inevitable augmentation of today's centralized grid infrastructure, right? So aggregation platforms for distributed energy storage and multiple customer loads similar to microgrids will be absolutely necessary if our energy infrastructure follows in the footsteps of telecom and the evolution of today's internet, right? So sometimes the virtual power plant we call IOE, Internet of Energy, because everything will be controlled through software. Later, little bit, we'll see whatever I have made it. No doubt the existing transmission grid will still provide the majority of power supplies to the industrialized world, right? But renewable distributed energy generation, that is RDEG, will also play a larger role in providing energy supply, reliability, security, and emergency care services, right? So actually, renewable means solar and wind mostly it is coming up like anything, and along with that, that battery energy storage system also slowly and slowly taking shape. Although battery is little bit expensive, but with the time when technology develops, with the time price will go down, right? So given consumer your pushback on smart meters, the very underpinning of the utility dominated smart grid, the microgrid represents an alternative business model for boosting the quality of grid services, particularly for end users, right? So nowadays everywhere you will find there are many microgrids, many any remote areas also one can see that islanded microgrid, right? And the operation of grid connected microgrid and islanded microgrid will be slightly different, right? Those are the beyond the scope of this discussion anyway. So utilities actually focus too much on the benefits meter data might bring to their own operations and forgot to connect the dots with consumers, many of whom saw only higher bills and no coordinated programs to respond to real-time price signals with tools that boost efficiency. And then there were the concerns about the data security. So I mean, if you start a business, you will, of course, you will try to make profit. That will be your objective. But at the same time, you have to see the satisfaction of the consumers, right? Or the product which you are selling to your consumer, they also have to satisfaction. If you see only your profit, then perhaps that may not be that attractive business, right? You have to think about the consumer also. The microgrid is one choice to aggregate, manage, and deploy distributed energy resources, particularly during a grid outage, right? When we are talking about distributed energy resources, that means DER, that means it is DG plus battery energy storage system. And when we call distributed resources, at that time it is only DGs, where battery energy storage is excluded. These are the certain terminology they use. Another aggregation option that is actually dependent upon smart grid upgrades is the concept of a virtual power plant, right? This virtual power plant, it actually Actually, it is a new concept, right? And although when we look into the literature, at that time, what we see that laboratory prototypes, this kind of work, maybe around 18-19%, maybe simulation type of work, which is mostly available in the research literature, right? Maybe around 59%, and field survey maybe 4% approximately, and theory maybe 16%, but real life project maybe 2%, because it is just started, right? So simulation works are more because it is totally software oriented, and price is the very important thing for your what you call for the virtual power plant, right? So different people give, I also defined some virtual power plant. Different people for given different type of definition of virtual power plant, but ultimately meaning of all these things converge into a same thing. Sometimes that virtual power plant may be defined as an aggregate of diverse players, namely generators and consumers. It is not there on the slide, and a diversity of energy resources, including electricity generation based on your several technologies, storage and demand response, right? So demand response is one of the prerequisite for virtual power plant. Little bit later, I'll tell you. Both of these aggregation platforms are emerging as viable options to boost reliability, your what you call shrink capital costs related to peaking generation plants and tapping demand response resources that can help mitigate impacts of your increasing reliance upon variable renewable resources such as solar and wind power. Now, when we come to the definition of microgrid, you people are very much aware of what is the definition of microgrid, but still microgrids have a long history. In fact, I told you at the beginning. In fact, Thomas Edison's first power plant, constructed in 1882, the Manhattan Pulse Station, was essentially a microgrid, since a centralized grid had not yet been established in those days, right? So by 1886, that means in 4 years, Edison's firm had installed 58 direct current microgrid, very low voltage, right? Very low voltage. However, shortly thereafter, the evolution of the electric services industry evolved to a state-regulated monopoly market, thus removing incentive for microgrid development, right? Now, this is what people say, that Edison's first power system or power station, whatever it was nothing but a microgrid in those days, right? Maybe it was DC generator, low voltage DC generator supplying power to few houses, right? The fundamental concept of a microgrid can be summed up as follows. It is an integrated energy system consisting of distributed energy resources and multiple electric loads operating as a single autonomous grid, either in parallel to or islanded from the existing utility power grid. Now, whenever microgrid is grid connected, at that time, that voltage and frequency will be dictated by the grid. So they need not control the voltage and frequency of the microgrid because it is grid connected. So grid will dictate. But when microgrid operates, in islanded mode, that is, it is isolated from the grid. At that time, you have to have your 1 DG at least for your droop control DG, such that your voltage and frequency need to be controlled, right? Renewable sources may be there, but you have to have droop control DGs, such that your voltage and frequency need to be controlled because it is isolated from the grid. And another thing is, which is beyond the scope of this, for island and microgrid, load flow to the conventional load flow slightly different. Different in this sense, at that time, as it is droop controlled, so frequency is one of the variable, that is either omega or f. That means in your state variable, apart from delta P, delta Q, you have to consider delta omega or delta F, right? And as the frequency is varying, therefore your X, the reactance will vary, right? So all sort of partial derivatives required for constructing Jacobian, and things will become slightly complicated, right? As far as computation is concerned. So that for island and microgrid, load flow study is different than the conventional load flow because of the delta omega or delta F. That is beyond the scope what I am telling you. So in the most common configuration, distributed resources are tied together on their own feeder, which is then linked to the larger grid at a single point of common coupling. These are you people are those who are slightly attached with this kind of research or this kind of study, you people are very much aware of all these things. Perhaps the most compelling feature of a microgrid is the ability to separate and isolate itself, known as islanding. from the utilities distribution system during brownouts or blackout. Immediately in Google, you can search what is the meaning of brownouts, right? Now, my question is that as soon as a microgrid is disconnected from the grid, that is islanded mode, that means at that time some DG should be there. It should operate in the droop control mode. Otherwise, how your voltage and frequency will be controlled, right? So those facilities should be there. Renewable sources there may be in islanded microgrid, no problem, but droop control DG should be there. But when it is connected to the grid, then voltage and frequency of the microgrid will be dictated by the grid. No need to control at the time. So under today's grid protocols, all distributed generation, whether renewable or fossil fuel, must shut down during times of power outages unless it can control voltage and not feed power back to the larger utility grid. Now, anyway, so there are, of course, microgrid is very much helpful for particularly the renewable side, and at the same time, as more solar, more solar and wind is coming up as renewable sources, so naturally your what you call burden on the conventional fossil fuel slowly and slowly will decrease, right? But overnight it is not possible, and at the same time, when electric vehicles are coming, right, and that means particularly during charging time, that you have to supply a lot of power overnight. All the vehicles cannot become electric vehicle. Then if it is off peak hours, if everybody goes for charging the batteries of the electric vehicle, then power station need to generate huge amount of power. So overnight it may not be possible, but slowly and slowly time will come when your what you call that lot of thinkings are going on, that your regarding charging the electric vehicle, including mobile charging van based on solar PV, right? Then battery to battery charging transfer, right? All sort of things are coming up. I was reading some article from Nature that how beautifully they're thinking of all sort of things. But today, whatever you think, tomorrow it takes the shape of the shape in the form of reality. Such sources could provide power services when the larger grid system has failed consumers. Recent advances in inverters necessary for solar PV and small wind turbines to convert DC generation into alternating current at a 50 or 60 Hz voltage level to synchronize with the utility grid are setting the stage for a viable microgrid market to evolve. Right. So new inverters allow for safe islanding. They enable this RDEG renewable to continue to operate when the larger grid goes down, thus avoiding the feeder fault concern associated with the synchronous generators, which may take 2, 5 or 10 seconds to respond to a grid outage. Right. So if there is a grid outage, then this microgrid can be isolated from the grid. And I told you, as soon as it will be isolated, some DGs must operate in droop control mode, because you have to control the voltage and frequency, and accordingly, locally the power can be supplied. Now, just I gave you the virtual power plant definitions. The virtual power plants, a term frequently used interchangeably with microgrids, rely upon software system to remotely and automatically dispatch and optimize generation or demand side or storage resources in a single secure web connected system. Right. This is how that virtual power plant can be defined. So in short, virtual power plant represent an internet of energy, because everything is your what you call software control, right? So basically it is an internet of energy, tapping existing grid networks to tailor electricity supply and demand services for a customer, maximizing value for both end user and distribution utility through software innovations. Now, this is actually some I have taken from some this diagram. I have taken the reference I have given here, right? So it is distribution automation. Monitor switch status and load, control to minimize outage impacts, control to optimize load flow. Now, capacitor automation, monitor status, monitor VAR requirements, and control to optimize VAR supply. Because all distribution side, you will find that some capacitors are connected, right? And this is automated, that is AMI, automated meter infrastructure, outage notification, automatic meter reading, monitor voltage and load, gateway to home area network, and demand response and distributed energy sources. Monitor or control end user devices, monitor or control DER system and devices, and your integrate into power system optimization. Everything, these are the switches. This is NC is normally closed switch, NO is normally open switch, right? So this is a schematic diagram, and this is the station, and this is the station, right? So this is a schematic diagram. But in Europe, a virtual power plant typically refers to aggregating supply side resources, most often a diverse pool of RDG and or wholesale renewable energy sources. But the term virtual power plant can also refer to the ability of commercial consumers to purchase capacity at the wholesale level via an auction from baseload fossil fuels facilities for a short period of time. Now, a virtual power plant may not involve generation sources at all, right? Instead, these virtual power plants tap utility demand response, because demand response actually is prerequisite for virtual power plant. Of course, smart grid is prerequisite for virtual power plant, right? And demand response is that is also required for virtual power plant, and critical peak pricing program, right? As resources that when aggregated can mimic characteristic of a traditional power plant, delivering peak capacity, energy or grid reliability regulation services when called upon by utility or independent system operator, right? So regarding virtual power plant, that whatever many things are there for virtual power plant, right? The structure, how the structure of the virtual power plant, its security and other thing, because everything is your what you call sorry, everything is software based, right? So, but based on certain existing power plants, some cases, some part of the world, the virtual power plant is working. But whatever I was reading, that in Japan, that they are constructing a virtual power plant, and it is coming up. It will take some time, and no renewable energy sources, nothing will be there. Only it is purely based on battery energy storage system, right? Purely a few, but future options should be there to integrate renewable energy sources. But this is perhaps this will be the first virtual power plant in the world, and totally based on battery energy storage system. So that means a unit converter, inverter, everything has to be there, DC to AC, AC to DC, whatever it is, right? So this is coming up. So without any large scale fundamental infrastructure upgrades, I mean, if it is based on existing one, virtual power plant can stage supplies from existing generators and utility demand reduction programs, delivering greater value to the customer, that is lower cost, new revenue streams, while also creating benefits to the host distribution utility, avoidance of capital investments in grid infrastructure or low capacity peak power plant, as well as the transmission grid operator, regulation services such as spinning reserves. When compared to fossil central station power plants that dominate electricity markets worldwide, one of the primary advantages of virtual power plants is they can react quickly to changing customer load condition, are dynamic and deliver value in real time, because everything is your software based. That's why they can react very quickly. The beauty of the virtual power plant is that it can optimize the entire system and deliver much greater value without the need for large capital investments in infrastructure and corresponding long lead times for implementation. But virtual power plant, that if you want to control that, if it is if you suppose a microgrid is there, it has to be grid connected. For islanded thing, virtual power plant you cannot use for islanded one, right? It has to be grid connected. Customer-owned generation sources, utility design demand response, and CPP is critical peak pricing, and even plug-in electric vehicles all become eligible candidates to help utilities solve grid balancing challenges. It seems likely that best way to deal with this increasing complexity evolving at the distribution level of service today is a virtual power plant or microgrid topology, or perhaps both layered on top of each other, right? So what is the generally that if you find out what is the similarity between a virtual power plant and microgrid, there are 80% similarities and 20% dissimilarities. Later little bit I have given. In the virtual power plant, in short, meshes the unique characteristic of all these potential resources into a virtual facility that can be organized by program type, supply side resource category, or location on the distribution network. Virtual power plants are really geared to helping utilities cope with the smart grid by aggregating a meaningful number of RDG and or that your distributed resources, your what you call customers, to reap the rewards of economies of scale in a whole new way, right? So whatever articles I am reading about virtual power plant, and my student also working on that, the PhD student on virtual power plant, right? So price is very interesting thing for virtual power plant, and some pricing thing need to be optimized. Like it is like those who are aware of demand response, price based or incentive based, or combine these to each other, try to combine both, right? Those, because according to literature, I can see that most your what you call very hot topic, this demand response, right? On virtual power plant also many articles are coming up, and price optimization is the important thing for virtual power plant. Instead of building bigger and bigger physical power plants, software and other controls enable utilities to aggregate resources on a short-term basis according to proximity, cost, environmental performance, and or other criteria. Like the microgrid model, virtual power plants are inherently flexible and modular, because since it is IT system and corresponding software is the glue holding the virtual power plant together, resources can easily be swapped in and out, depending on the ever-changing requirements to keep grids in balance or to lower customer costs or display dirty fossil generation during peak periods of demand. A key distinction between a microgrid and a virtual power plant is that the latter is not limited by geography and static set of resources, as is the typical microgrid. With the emphasis on smart meters, real-time pricing, and demand response, the smart grid is actually a necessary prerequisite for virtual power plant. Therefore, for virtual power plant, the smart grid is prerequisite. What distinguishes a virtual power plant from the smart grid is that most virtual power plants attempt to create a mini independent system operator on the customer side of the meter to optimize energy resource aggregation, and of course demand response is required for virtual power plant. Virtual power plants are likely a natural evolution of the smart grid and are highly synergistic with the more sophisticated billing systems that are emerging as hallmarks of backroom operations supporting the rollout of the smart grid. Now, microgrid versus virtual power plant. Virtual power plants and microgrids share some critical features, such as the ability to aggregate demand response, RDG, and storage at the distribution level. Some market participants estimate an 80% commonality between these two business platforms. Yet there are some defining differentiators. So 80% similarities are there between microgrid and virtual power plant. Now, microgrids can be grid tied or off-grid remote system. Virtual power plant are always grid tied. Microgrids can island themselves from the larger utility grid. Virtual power plants do not offer this contingency. Microgrids typically require some level of storage. Of course, without storage also microgrid is possible, whereas virtual power plants may or may not feature storage. Now, microgrids also may or may not feature storage, so more or less same. Microgrids are dependent upon hardware innovations such as inverters and smart switches, whereas virtual power plants are heavily dependent upon smart meters and IT, that is software. Microgrids encompass a static set of resources in a confined geography, whereas virtual power plant can mix and match among a diversity of resources over large geographic regions, because it is software based and internet, right? Internet through internet only. So it can so distance is not a problem. So diversity of resources over large geographic regions. Microgrids typically only tap DER at the retail distribution level, whereas virtual power plant can also create a bridge to wholesale markets. And microgrids still face regulatory and political hurdles, whereas virtual power plants can more often than not be implemented under current regulatory structure and tariffs. Of course, this varies from country to country. According to rules and regulations, this varies from country to country. Due to the lack of current standards, a variety of microgrid models are coming up. Some are focused on reliability just within the microgrid itself, whereas others are focused on maximizing economic opportunity by selling your excess energy services to a larger grid. Some models that cross over to the virtual power plant category would operate on the transmission side of the substation, aggregating, optimizing, and then dispatching, though the vast majority would function below on the distribution side. Look, long time back, when I was doing my PhD or research, and in those times, that people mostly concentrating research on the transmission side, power plant side, right? At that time, suppose till your end of 80s, nobody was looking much on the distribution side, and in those days, hardly you will find research paper on the distribution side, very less, mostly on the transmission side, right? But after 90s and till today, you will find that people are mostly concentrating on the downstream, that is the distribution side, right? So with the time, everything is changing. So nowadays, you will find plenty of research article on the microgrids, on microgrid, grid connected microgrid, islanded microgrid, and research on the distribution side, right? Several articles are available. Maybe many of you are working also on it. Some model that cross over to the virtual power plant category would operate on the transmission side of the substation. This I told you, right? Majority on the distribution side. Now, other microgrids never interact with any larger grid and are focused on reducing diesel fuel consumption. In the microgrid also, diesel generator may be connected. So, virtual power plant market forecast. Unlike microgrids, utilities will have to play a major role in the evolution of the virtual power plant market. With its emphasis on smart meters, real-time pricing, and demand response, the smart grid is actually a necessary prerequisite for virtual power plant. What distinguishes a virtual power plant from smart grid is that most virtual power plants attempt to create a mini independent system operator, mini ISO, on the customer side of the meter to optimize energy resource aggregation. This mini ISO is required. Those who are aware of demand response, they may be knowing that, knowing it, that why your what we call independent system operator is needed, right? So demand response is a very hot topic of research, I have found. Of course, I am now very old man. Those who are young person, they have a better opportunity to work on this one, right? So virtual power plants are likely a natural evolution of the smart grid and are highly synergistic. This I have told you before, with the more sophisticated billing system that are emerging as hallmarks of backroom operations supporting the rollout of the smart grid. Now divides up the virtual power plant universe into 4 distinct segments. Now demand response based virtual power plant. This is the largest commercial segment and needs most mature demand response market. This demand response is a very sophisticated thing, right? Suppose in your house you have a dishwasher, you have a washing machine, you have geyser, you have a microwave oven, right? So if you know which time it will operate, and if you send the signal to the your what you call next day, what will happen? So accordingly, all will be all will be collected together information, and accordingly, every hour you will be knowing the demand, right? So this is actually mature demand response market is required. That means you need to have your sophisticated your what you call sophisticated technique, right? Everything will be software based. And supply side virtual power plant. But first one is very common, right? And your lot of research started on this virtual power plant using the first one. Europe has led the world in this category, that supply side virtual power plant. Though most of the projects have been in R&D pilots, with only a handful of virtual power plants in commercial operation. Mixed asset virtual power plant. This is the ultimate goal of the virtual power plant, bringing distributed generation and demand response together to provide a synergistic sharing of grid resources to squeeze out more value, thereby reducing capital cost. Few of those projects are in commercial operation today. I told you hardly 2% all over the world. Whatever data I have seen. Now, wholesale auction virtual power plants, unique to Europe. Virtual power plant auctions have been used in Europe as a condition of mergers requiring asset owners to auction of base load and peaking capacity to bidders under short and long-term contract. Unlike the category of supply-side virtual power plant segment, these resources are typically traditional centralized power plant burning fossil fuels. Microgrid market forecast. Look, whenever you start a business, you have to see you have to survey the market, whether your product will be selling or not, right? So the lack of clear market for carbon-free energy hindered the evolution of the green technology, green job sector, further dissipating momentum in green power and distributed energy market, reducing the need for near-term microgrids. The stimulus funds deployed on behalf of the smart grid have, in some cases, been treated away on poorly designed rollouts of smart meters and automated meter infrastructure, and have underwritten utility overhead charges instead of creating new jobs linked to thoughtful and effective grid upgrades. Actually, this lecture, I was not aware of this last evening also. When Shivam sent me the mail this morning, I recall something I have to tell. Otherwise, I should have, I could not collect so many things. Right. I no time, whole day I was busy in the department, morning and afternoon. Right. In any way, so 3 references I'll show you. That first reference will really help you. It is 2010 or 2011. Year is not written. And the last reference, that is this paper is a fantastic paper. A microgrid energy management system based on the rolling horizon strategy. It's a fantastic paper, very highly cited paper. This one can go through this paper, and really will see that what is definition of smart grids. Many people see the definition of smart grid. So if you want to know what is definition of smart grid, this paper one should read. There are 6 or 7 authors are there in this paper, and it is a fantastic paper according to me. I mean, whatever I feel, right? So this is whatever this thing about smart grid and virtual power microgrid. Another little bit thing I will tell. This is your this thing, zero bus load flow. This is also related to microgrid. Actually, while we are doing that economic load dispatch of AC/DC microgrid, at that time this concept thought came to our mind, because we are thinking that how to solve this. For example, those who are aware of distribution system research, that generally what you do, you treat substation as a slack bus generally. That means this way we are solving the load flow. But suppose your distribution network, say it's microgrid, is purchasing power from the grid. Therefore, at the substation, generally if you treat as a slack bus, then V delta both are known, right? And P and Q are unknown. So in there, but if P and Q are known at the substation, because you are purchasing the power from the grid, then what will happen that P, Q, V delta, all the 4 quantities are known at the substation, right? So if it is known, then you cannot solve the load flow, whatever conventional Newton-Raphson load flow method, you cannot solve it. Therefore, you have to have one bus that is called zero bus, where all these 4 quantities are unknown. Then only your Jacobian will match in the form of n into n matrix, right? So this thought came to our mind, that zero bus load flow. And this zero bus load flow, based on whatever load flow equation you have studied, same thing, everything is same, only Jacobian formation will be slightly different. So little bit I am telling in next 20 minutes or so. Already throat continuous talking, throat is trouble has started, right? Now think these are all common to you, those who are studying, those who are in power system, and those who are teaching power system load flow studies. These are known to all of you, right? So nothing is new. I am not telling any new thing. So this is bus I.
Excuse me, sir. We can take a break of 10 minutes if you want.
No, madam. Thank you very much. I'll continue. Actually, some nodules has formed in my throat. That was detected some 4 and 5 years back. So after that, in the class, whenever teaching, I am taking a little bit of water, then teaching little bit on microphone I am using. Right.
Okay. Okay, sir. Thank you, sir. Thank you.
So this has happened because of my not only me, for many others maybe. The decibel is very high value in the classroom, because I shout a lot in the class. I mean, my my voice raised to any level. Like many, not me, many others also had the same problem. I had also developed same problem. So this is your voltage. This is bus I. Then current injected, say at this bus is II, this capital II, and these are it is a typographical mistake. These are small YI. I mean YI1, YI2, all small. It is not capital, although it is typed as a capital. So if you apply KCL here, then total current II will be equal to sum of all the current flowing through this, right? These are available in standard book, any book it is available. Stevenson, your what you call nowadays it is your at another person name is attached to Stevenson. Original Stevenson book I have, or any other power system book, you can see this, right? Then this is actually then current flowing to this is yi1 vi minus v1 yi2 vi minus v2 and so on. So this is your write down this equation and then collect the common term. So vi into this plus your minus of y v1 plus minus of yi2 v2 and so on, right? So this equation can be written as vi yii plus v1 yi1 v2 yi2. Ith term is written first because ith term will be taken out, right? And this is your where yi is equal to this much, and this is your diagonal, and this is off diagonal. These are all known to you. Those who are teaching power system, all known to you, right? Nothing is new here. So the expression III can be written as YII plus sigma k is equal to 1 to n, k not is equal to I, YIK Vk. This is also known. Now, you know your power, your what you call that your power injection formula, that your Pi minus JQI is equal to Vi conjugate II, this one, right? Sometimes I ask, why do we select conjugate? Right, just arbitrary to you have not selected for electrical engineering. Sometimes you ask this question, it is nothing but to capture the power factor angle, that is the angle between the voltage or current, if the voltage and current waveforms are purely sinusoidal, right? That's why you use conjugate to capture the power factor angle. Of course, voltage and current waveforms are purely sinusoidal. So anyway, this II you substitute here. Accordingly, your what you call, you will get the expression of Pi and Qi. This is all standard book, it is available. This Pi, Qi all available, right? So nothing to discuss about this thing. These are any book, it is available. All right. So this is Pi, this is Qi. Now electrical power system. So whenever we are thinking that if microgrid can purchase power from the grid, that at a substation that power will be fixed, P and Q both will be fixed. So if it is so, then we are there at that time. We I mean, student and myself, we discussed, and finally we thought that we have to have, if we want to form Jacobian matrix, we have to have a bus called zero bus, where all quantities are unknown. So this way we constructed, and we got paper also, couple of good papers also, right? So this way, your what you call this PQ V delta are considered as the main parameters to represent a bus. This is known. Every bus, 4 quantities are defined. 4 quantities are there: PQ, V, and delta, voltage magnitude and voltage angle. So one is slack bus. It is known to you that voltage and angles are known. PQ are needed to be determined. That is slack bus. Another is PV bus, where P and voltage magnitude are known. Q and delta are required to be calculated. Load bus or PQ bus, in which P and Q are known, voltage and delta are needed to be determined. So in this considered problem, all the 4 parameters P, Q, V, delta of the utility of slack bus are known. So it is not a slack bus now. Slack bus, utility or slack bus we can call, but voltage magnitude and your what you call bus voltages, voltage magnitude and angles are known. At the same time, P and Q are also known. This kind of bus can be called as PQ V delta bus because all 4 quantities are known. On the other hand, DG needs to be placed at the load bus. For a load bus, voltage and angles are required to be determined. Later, I'll tell you how we have done it. At the same time, the DG size is also needed to be optimized in order to minimize the network active power loss. So you have to choose a zero bus. So arbitrary bus you cannot be taken as a zero bus. You have to choose that bus as a zero bus. Zero bus means that bus where P, Q, V delta, all 4 quantities are unknown. So that bus such that your power loss will be minimum. That way you have to find out which bus is a zero bus, right? So zero bus we are calling as because zero number parameters is known. This kind of bus can be called as a zero bus, right? Therefore, skipping this one. So utility PQ V delta at substation, these are known. Zero bus where DG needs to be installed, unknown parameters. Rest are the load buses. No PV buses considered. Now using Taylor series expansion, delta P or delta Q, these are your what you call, these are any book you will find this derivative. Any book you can find dpi delta delta 2 delta delta 2 dpi delta delta 3 into delta delta 3. These are available in any book. Nothing is new. I'm not writing anything new. Delta QA also same way you can find out. Now, if you put now here, Jacobian will be slightly different. Look, bus 1 is not a slack bus, right? It is a PQV delta bus. So delta P1, delta P2, delta Pn, delta Q1, delta Q2, but I not is equal to D. D bus is a zero bus, right? So I not is equal to D. And this side accordingly, if you find this column, at bus at your slack bus 1 substation utility bus, delta 1 is known, right? And V1 is known. So starting from delta 2, delta 3, delta D, delta N. Similarly, delta V2, delta V3, delta VD, delta N. D bus is a zero bus, right? And accordingly, all inside that you can form the Jacobian. Looking at this column only, you can find out the Jacobian, right? So this way you can form the Jacobian matrix. Newton-Raphson method only, coupled Newton-Raphson method, decoupled may not work, right? We didn't try, but may not work because it is a low voltage network, right? So now all this thing P and Q Pi Qi expressions are known. According to all these derivative, all these you can take the derivative, and all these elements can be computed. So all these elements are computed. These are also known, same as your whatever you have studied, right? So, and these are the power, and these are your what you call power loss. I am not telling you know all these things. Power loss equation in general I square R, right? So similarly, objective function utility power plus DG power will be load plus P loss. Similarly for Q, right? Similarly for Q. So you have to optimize minimum. You have to optimize that your power loss should be minimum. Now, what I'll do, for 33 bus distribution network, I'll come. Suppose bus 1 is a PQV delta bus, right? Then which bus you will choose as a your zero bus? You have to find out. That means what you will do, you consider one bus at a time, and that bus you take as a zero bus, run the load flow using that whatever Jacobian I have said above, using this one. You run the load flow, right? And you run the load flow, and accordingly you will get your what you call and find out the loss. Similarly, forget about this. Consider another one. This way, suppose 33 bus means you have to run 32 load flows, right? Each one you take one bus at a zero bus. After that, you will find which bus. After that, you note down the power loss every time, and then you find out which bus is giving your minimum power loss. That bus should be considered as a zero bus, right? For this example, if I recall correctly, I think bus 633, whatever you people are using, many of you are using this data. I think 6 bus was the zero bus, right? I mean, giving the best result. This is for 33 bus. Similarly, for a 69 bus also. Here also same way you have to do it, and you have to find out the zero bus. What we have you're actually done is, these are some graph and other things showing. What we have done is, nowadays, if you do for a particular only one load level or only one load, and if you try to do something, you can do it. But when you send articles, no, they do not give that much of importance. What we have to do is, we consider the load, annual load profile. I mean, 4 season we divided: winter, summer, spring, and fall. Then each season we represent it by equivalent to 24 hours, right? And accordingly, so 24 into 4 means 96 hours representing one season. Sorry, 1 year. Multiply by 91.25, it will be 8,760 hours. Otherwise it is difficult. I mean, if you take 8,760 hours every hour, if you do, then that will be very cumbersome and laborious. So this, and at the same time, the load profile weekend and weekdays will be different. Weekdays Monday to Friday, it will be different, and weekend Saturday and Sunday load profile is different. So we consider your what you call that your weekdays data and weekend data. Accordingly, we have taken, and for solar thing, at Kharagpur IIT we have a 100 kilowatt peak power plant. So we have taken that pattern. We have not considered that 100 kilowatt generation as a, just whatever may be the peak load, divide every hour solar PV generation by that, such that you will get a pattern. That's the highest is 1. So that pattern we have used. And for wind power, we have taken data from another place, right? Accordingly, we computed the wind power. Both are annual. I mean, our case, that solar power plant, if you want data for every 15 minutes, it will be available. If you want for every 1 hour, it is available. So we have used totally your annual solar data, and after that we have averaged it. How we have done it? For example, suppose in the summer season, right? Suppose today at 8 o'clock, whatever may be the 10 o'clock, whatever may be the solar power, tomorrow at 10 o'clock, next day at 10 o'clock, whatever may be the power, that we added and divided by the number of that number, right? Such that we can get some average pattern. Accordingly, we have done it. Otherwise, it will be huge computation. And this way, that your zero was thing we have done it, because we needed it for economic load dispatch, and your what you call. Nowadays, most of you and maybe many faculties are there, many students are there. A research focus is totally converged to microgrid only. Most cases. Whether it is control side or whether it is economic side. I do economic side, not the control side, right? Economic side. So nowadays, whole research has focused to this thing. When I was young, there was no research on microgrid. When I am old, now research is focused. Now those who are young now. And second thing is, nowadays, that getting paper is a very tough thing. You have to do something. Those who are researchers, you have a very tough thing to get paper in a good journal, right? So one has to work very hard nowadays. So thank you very much. So anything else if you want to ask is okay. If I know answer, I'll say no. If I do not know answer, I'll say I do not know. I think last year, July, I gave one lecture on renewable sources. I think if I recall correctly, it was in the month of July 2021. Probably this thing. At that time, I talked something about renewable sources, solar and wind, that thing. And regarding this zero load flow, we got this is our this is the paper in energy. We got it in 2019. Right, Vikas, then Mukherjee, and myself. Anyway, Shivam, from my side, thank you very much. Now, from other side, if they want to ask anything.
Thank you, sir. So
already third problem started.
Okay, sir.
This thing you needed. No, I'll mail you after this.
Okay, sir.
Okay.
So just
shall I share the stop sharing? Stop sharing?
You may, sir.
Now tell me.
Okay. So I call participants. If you have any query, you may ask here.
It was a very nice exposure, sir. You are very right. You have given a lecture in July also to the NIT students only. Actually, this is a different platform, and we have different type of exposure. But sir, I have one question. That you were telling us that we have the virtual, we can have virtual grid, not in islanding mode, along with the grid, main grid, as you were giving the example of Japan. But if you are using batteries, you can charge your batteries by renewable only, or you can charge it through grid. Then I think it has no meaning. So
whatever you are telling, it is all right. In Japan, they are constructing this virtual. Whatever I read, you can also get it, madam, from the internet, right?
Okay, sir.
They are constructing the virtual power plant based on battery energy storage, right? And of course, no renewable option is there. But of course, if battery is there, you need to be charged also, right? That is not written anywhere. Or this thing, definitely battery need to be charged, otherwise how power will come?
Yes.
Right. Yeah, right. So that is not written, but whole process what they are doing is that totally it will be based on battery energy storage, and huge money is involved, and rating is also very high. I don't know, few hundred megawatts exact. I cannot recall, I have to see. And it is coming up. Several other utilities or other companies from other countries also involved in that, and they are calling this is the first virtual power plant in the world when it will come through. I mean, totally, it will be called as a virtual power plant. And whatever telling you are, it is right, madam, that battery energy storage means you have to have charge, otherwise from where power will come. That is true.
Because they are having batteries, so they will not have intermittent sources, because these sources, wind and solar
No,
are intermittent.
they have not kept any provision at present. Whatever I read is solar and wind, nothing. But in future, the future provision will be there. Currently, only based on battery energy storage and virtual power plant.
Okay, sir.
And
Thank you.
few research have come, but most of these simulation studies. My student also doing simulation on this virtual power plant pricing and other thing. But mostly practical, if you do real-time operation, 1 or 2% hardly all over the world.
Right. Because battery can give you continuous power. So that is
yes, madam.
that will help.
Yeah.
Thank you, sir. Thank you so much.
Okay.
Any other question from the participants, please?
Sir, one Chetan is here. He will ask some question. His question is, how can we consider different load profiles, effect over week, month, year for economic dispatch problem?
What he said, different load profile. Different load profiles, you want to mean your seasonal load profile, summer, winter, fall, or this thing, or constant power load, constant current load, constant impedance load, or mixed load, or some different forms of loads are there. So economic load dispatch, if you do, I mean that if you can consider variation of different load, I mean, if you need 1 year load profile data, what we have done is we took something, I think I cannot recall, but some IEEE articles are there, old article 1996 IEEE reliability test system. There some data are there. What we have done, we have normalized that data. Whatever they have given, we have normalized, we have taken the pattern. Accordingly, we have applied to this your distribution or microgrid side. So that was IEEE 1990 reliability test data, but economic load dispatch also people are doing it, but I am not familiar with economic load dispatch of transmission side or that, right? I do only on the microgrid side or distribution side. So I'm not familiar with that kind of thing. But if you to consider that economic load dispatch, I mean hourly basis, if you do, then things will be better. So every hour load will be different. But similarly, I am taking from my intuition, I may be wrong also, that similarly the seasonal variation you can take, represent 24 hours a season, and accordingly every hour you can do it. I think this way perhaps it will work. Although I am not familiar with the research of economic load dispatch of this higher side, only lower side I do it. And
okay. Is it okay, Chetan? You can ask. You can unmute, and you can ask this. Yes, he replies, sir. Thank you, sir. He replied, thank you, sir.
He is a student, no? Work
Yes,
hard,
sir.
work hard. All students, I am telling nowadays, work hard for PF. If you are a research scholar, work hard for paper.
So now here, Jyoti, you may ask.
Sir, those data can be get from the grid controller of India, sir.
What? Tell me.
Sir, earlier it was known as Power System Operation Corporation, but now it is Grid Controller of India. So they update their voltage profiles, load profiles every day, sir, in their website. So
no, what you are telling?
So the daily basis, they in their website, they upload some reports, sir.
No, if you are doing research, you want to data, let me tell you, we also wind data we have also taken from one India only. So
Okay,
it was that link was given. So accordingly, wind power generation data we have taken from that link, right? Nowadays
yes,
we
sir.
found which one I will not tell here, right? But nowadays that link is not available. But as we have made it, this thing. And solar data we are using because our Kharagpur IIT, we have one, so we have many solar PV panel, but 100 kilowatt peak plant is there. We have used the pattern, not the rating. Just whatever maximum generation, you divide each hour by the generation such that maximum is 1 and it is normalized, right? Dimensionless
Yes, sir.
quantity. That
Yes,
one we
sir.
have used. So I'll tell you interesting thing. One reviewer asked question that you have used solar data from this place and wind data from this place. So, but you are applying to certain how things. I said, we have replied also, if we have the data from the same place, only data need to be fitted as a result can be obtained. Right. But data, but whenever you do solar and wind, I suggest you take the some practical data from somewhere. That will your give the, that will make attractive to the your reviewer when you send the paper. You try to take, don't take any hot fuzz data, try to take some realistic data that I have taken this data.
Okay, sir. Okay, sir. Thank you, sir.
Any
There is a
more?
program called REMC, sir.
Hello, hello.
Yes, sir. Am I audible, sir?
I can hear you.
Yes, sir. There is a program called some REMC, sir. RE Connect, there is a, like one platform is there, API. So it's renewable energy management on the center, sir. So from there, they also like validate and updates the data, sir.
Many are using that. If you get the availability of data, no,
Yes,
I will
sir.
only say use that data and cite all the time. You will cite. Don't hide anyone, right? From
Yes,
where
yes.
you have taken data, yes, you have to cite. If you write any article, you have to cite that I have taken this data from this reference. Many are not
Yes,
doing
sir,
it.
yes.
Many are not doing it. Many are hiding. I am aware of many things, but all the time you should cite and use practical data. This is my
Okay, sir.
suggestion to everyone. Those are use solar, wind, use practical data.
Okay, sir.
You are from Assam.
Yes, sir. I am from Assam, sir.
Looking at your title, I can. Which place?
Guwahati, sir.
Oh, Guwahati. I went to Guwahati many times. IIT Guwahati, I went to many times.
Well, I am here in, sir, in Delhi only, working in National Law Dispatch Center only, sir.
Achha,
So
achha.
there I do SCADA, sir.
You are working in Delhi.
Yes, sir. They're working
Okay.
in Delhi.
Oh, good, good.
I do SCADA in National Law Dispatch Center, sir.
SCADA, no?
Yes,
Yes,
sir.
yes, yes. Good.
Thank you, sir.
Anything?
Good evening, sir.
Good evening. Good evening.
I am Shahzad Hassan from MIT Muzaffarpur, sir.
Uh,
Actually, sir, may we get the PPTs which you have shared?
I will send it to Shivam. After this,
Okay.
as soon as I'll get out, because he wants that, I'll send it to him because they
Okay,
need
okay.
it. For me, it is nothing. If you want everything, I'll give it. For if it helps somebody, it is okay.
Yeah, yeah, sure. It will be very much helpful for us, sir, if you provide, sir. I will take from Shivam, sir. Okay.
Okay.
Okay. Thank you. Thank you very much, sir.
Thank you, sir.
Okay.
So, sir, just I am asking to once again to participant. If you have any query, you can ask here.
Otherwise, you can mail me also.
Okay.
Right. I reply to. I try to immediately not,
Yes,
but I try to
yes,
reply
I will
everyone.
share your email ID to them, sir. If you have any query, you can put such type of question. Yes, sir. I have one doubt here. Virtual power plant. Basically, it is developed for grid connected mode. So, just I am interested, sir. Can this implement for islanding mode, sir?
No, a islanded mode, because if it is listen, if it is isolated from the grid, right, then you cannot do that, because it depends on the demand response program that is prerequisite. And generally what happens, if it is grid connected mode, only that portion it is controlling to software, right? But if it is totally isolated, And if it is in that case, what will happen? Voltage and frequency, you have to have at least one loop control DG must be there, right? So at that time, you cannot get power from the grid, right? It depends on many things. It accordingly, your mini ISO is there. According to demand response, it sees what power is required at that time, and accordingly, if that power comes from the grid, it is totally software control. But if it goes off, then from renewable, whatever I know, Shivam, I know it is not possible. So whatever may be the power you have for islanded mode, because those conditions cannot be fulfilled. So only it is grid connected mode, not islanded mode. But islanded mode, let me tell you one thing. I have several research students at present. I think I have 8 at present, right? And for all of them, I am the only guide. Remember that. No co-guide. I am the only guide. And I spend time all the time with them. Perhaps you young people, I can beat young people also in terms of spending time with them, right? So this way, I am also learning from them, right? It is a bilateral this thing, and I have no ego. Whatever question you ask, I have no ego. I have no ego. Nothing I have. I sit with them. And this way, for virtual power plant, we come to that. I asked one of my students, he's a good student. I asked that let us start at least before my retirement, let us publish 1 or 2 papers on virtual power plant. So he's working on it. Most important thing is virtual power pricing. Demand response, we have done it. I have many students, they're doing it also, right? But question is that in the virtual power, pricing is not known. So how to optimize the price and other thing, that part only we are doing for virtual and reading and trying to understand what they have done it. But my suggestion is, if facilities comes in future, if people can try to do it in laboratory level, right? That how things can be done. But if it is islanded mode, as you are telling, solar and wind, if it is there, suppose islanded mode, solar, wind there, loop control DG will be there, but it cannot supply power to the consumers as far as unless it is not connected to the grid. This is what I know. Latest paper, I have many papers. I have not seen anywhere that it is your islanded mode. Are you doing anything on islanded mode?
Yes, sir. I publish papers, sir, in islanded mode, sir.
Islanded mode load flow is different.
Yes, sir.
And loop control, loop parameters need to be optimized at every hour, right? Every hour load is different. Every hour your loop parameters, both there are 3 different type of loop characteristic as used. One is PV, one is your PF, QV, another is just opposite PV, QF, another is your combination of both, right? 3 different type of combinations are there. So accordingly we do it.
Okay, sir. So from my side, it's over, sir.
Okay, thank you. Anyway, last time I don't know when I went to Kurukshetra, maybe 2017 or 18. Last time I went.
Yes, sir. You came, sir, in 2018, sir.
17 or 18.
18, sir.
Yes,
in sir, 30 April, sir.
And I will also visit Nagpur very soon. Now, 3 days back I went to Imphal, Manipur, right? Yes. And in next few days I'll go to Nagpur. VNIT Nagpur.
Yes, sir. Thank you, sir.
Okay, thank you.
Thank you so much, sir. You have given time in such situations, sir.
No, at present, no class.
So
no, we are free. At present, class is not there. Okay, then thank you. So I am taking leave.
Thank you for being with us. Okay, sir.
And I am sending you that PPT and the other form I am just sending you.
Okay, thank you, sir. Thank you so much, sir.
Okay, thank you.
Thank you, ma'am.
Okay, welcome.
So all participants will be joined tomorrow at same time. Same Zoom link will be active. Okay, thank you to everyone. Thank you, ma'am.